Hello, everyone, and welcome to our webinar today about building an edge platform with UCPE. For those wondering, UCPE stands for Universal Customer Premise Equipment. My name is Mikel Echegoyen from Tieto Every, and I'll be your host for the next 30 minutes. And your expert today will be Martin Iponyi and Nang Wang, who we also call Toby. So Martin is a technical project manager and a business developer for cloud and edge solutions, and he's based in Phoenix, Arizona, and he's working with large customers on cutting-edge cloud solutions.
Yeah, hello from Phoenix, Arizona to everyone.
And Toby is an engineering manager leading our team in Chengdu, China, and he has a long experience with delivering cloud solutions to our customers globally.
Hello from Chengdu, China to everyone.
So thanks to both of you guys for being here today. Before we kick off, just a few words on practicalities. So if you're having any questions, you can type those in the question box in your GoToWebinar tool. We'll do a Q&A in the end of the session. And if some of the questions are unanswered, we'll get back to you by email. Also, if you're having any issues with either seeing us or the presentation or having some audio issues, you can also let us know through the chat. Well, let's move on with the agenda for today. So basically, in the first part, we'll talk a bit about edge computing and some of the use cases that it enables. And then we'll talk a bit about one of the use cases that we have prepared for today. And Toby will walk us through our UCP solution and also how to deploy and some of the use cases and also the technologies we have used for our platform. And then we'll wrap up, as mentioned, with a Q&A session. So that's about it. Let's get started. Martin, are you there in Phoenix, ready?
Yep, absolutely. Okay, so let's start from the beginning. Let's talk about the edge computing itself. So there's a lot of discussion about the edge computing nowadays. What is in fact this edge computing all about? So at the basic level, edge computing brings computation and data storage closer to the device when it's being generated, rather than relying on the central data center, which can be like 1,000 miles away. In practice, this means that the majority of your data is processed locally on the edge of the network, giving great benefit of low latency and saving on the operational side, as your massive data don't need to be sent to the data center to the core network anymore.
So can you give us some examples, Martin, about edge computing use cases?
Oh yeah, sure. So first of all, it's worth to know that introducing edge doesn't replace use of the data center or public cloud. The edge computing brings a lot of value for the specific use cases, especially those connected to the IoT, connected offices, or industrial solutions. Let's take the example of your a daily Netflix streaming. It requires a lot of data storage, so to bring it closer to the user to edge may not make sense from the cost perspective, especially that edge computing was not really intended to have an unlimited scalability. Situation looks differently in the case of the POI, like a point of the interest use case, where we can use city surveillance camera to look for, an example, person or a car in the city. Traditionally, all the cameras would be streaming high-resolution data to the distant data center, introducing high latencies and overloading core networks. We are talking about 100 parallel streams. What creates whole operation not efficient and much too slow, as the car on the person may be really on the go. So using edge computing, our processing is done close to the cameras. Edge nodes do all image processing based on the pattern delivered by the data center app, so like a point of interest image, and send back on the location when the POI is found. It saves time, bandwidth, and of course make search much more effective. Isn't that a smarter solution?
Yeah, I can see some benefits, of course, for such use cases, but do you have any others to add?
Oh yeah, of course. So there is a plenty of those connected to the IoT, to the agriculture, automotive, SDN, and much more. Let's take an example of the SDN-based connection between two branch offices, which we are going to talk about today. Now it can be handled by the, like I said, point-to-point connection between two edge nodes without connecting to the core network, and the edge nodes itself may find the best and quickest route. Another good example can be one of the industrial or the agricultural ones. Let's take, for example, the agriculture company growing the corn in more like than 100 fields in the 10 countries. Each of the fields may have hundreds of the sensors, cameras, which based on the AI algorithms may learn how to dose water or food for the plants to get the best results. Of course, again, here all the data, massive from all the sensors, will be processed locally on the edge, and then learn patterns may be shared between the sites with use of cloud to get the best results.
Yeah, so that looks interesting, but I'm just thinking, how do you make this in practice if you need to send hundreds of people to sites everywhere in the world?
Yeah, you're right. So it's if you would really need to send these guys, all over the places, it would really create a huge cost waste on the whole operation. But here's some, additional solution come handy. Let's take an example of the CPOs we are to talk about today. It's a typical device to be deployed on the edge. It may serve as a router at your home or company. The basic software stack of the device is like for sure provides like a lot of flexibility, functionality. It's nicely virtualized and flexible. However, it doesn't help to easily operate remotely. However, if you add on top of the stack orchestration component dedicated for edge, this will change the game. In our case, we have selected Open Network Edge Service software, so-called OpenEdge. It enables you to have a full remote access to the device, including configuration of the services, stopping, starting, with practically one click. Moreover, we are working further to integrate Arcano and ONAP to the solution, so ultimately you will have a one point of orchestration for your services wherever you would like to run them on, like in your office, maybe on edge, maybe local, all the central data center, or maybe in the public cloud.
So coming back to the use cases, can we perhaps look at the one you have prepared for today?
Yes, definitely. As mentioned before, today we would like to show one of the like a typical SDN use cases. So basically how to use edge computing to connect seamlessly and securely to branch offices.
And then I almost forgot to ask, you already mentioned quite a bit of software. So, are we talking about, substantial licensing costs for the software?
That's a good question. So it usually is a big concern when building edge solution or well any other software-based solution, right? However, the one presented today is fully based on the open source software. So all built based on the cloud native principles. Like one of them says to have your solution modular, so you can swap your service application freely and use either commercial or purely open source. There is also a lot of support in the open source community with a lot of contributors building both infrastructure or the application, cloud native application itself. Like for example, CNCF or CNTT. So maybe let's look then on the problem and the solution proposal we have prepared for today's session.
All right, thanks, Martin. Toby, are you ready to walk us through the solution?
Absolutely. Let's look on the branch office connection use case here and the disadvantages of using like two normal gateways to connect those two offices. This diagram depicts a traditional way to connect two offices through two gateways. If you want to have two WAN ports like it shows in the picture, then you have to buy really advanced routers, and those routers are needed to be configured and managed separately by local teams. A lot of communications and synchronizations are needed to align between two sites. Basically, there's a lot of time and operational cost involved on a regular basis. Additionally, please note that those routers provide only connectivity.
Yeah, I think that sounds quite expensive and not very scalable, right? But can you tell us perhaps, how UCP will help in this case?
For sure, let's look on depleted solutions with Edge and UCP employed. First of all, UCP is a white box hardware and software. It means that it can be easily deployed to generic servers of any size, or even some embedded systems. Uh, no specialized dedicated box are needed anymore. At the same time, using user space stack provides same or even better performances comparing with dedicated routers. By the way, you can always propose generic servers if you don't need the solution anymore and run anything you want on it. Coming back to the solution, using SD-WAN controller makes configuration, operation, maintenance centralized. It can even connect to automated orchestrator like ONAP, what gives you a full zero-touch service orchestration. And at last, the applications, for example, like Wi-Fi wall, SD-WAN, etc., can be deployed and managed by the Edge platform, what streamlining the operations even more.
Yeah, I think that sounds great. Could we perhaps look at the solution architecture? Yeah, I'm just thinking if moving everything to software is making things quite complicated.
So let's go through the architecture diagram very quickly. Actually, the platform software stack is divided into four major parts. One is the hypervisor, of course. Docker is used in this case. And the second one is NTS, we call Network Transportation Service. It is a networking layer responsible for communication between box and overall data plan traffic. We're using VPP here. It is easy to connect the edge applications together. And in some case, we can even create SFC, the service function chain, through this layer. And Edge agent here is to manage the full life cycle of applications running on the UCP platform, including deployment, starting, stop, and monitoring. Um, and finally, the edge applications, all the services provided by UCP is abstracted as edge services, including SD-WAN. With this kind of architecture, the UCP platform is super flexible. All the service applications could be customized according to your needs. For example, you can replace the SD-WAN application with your own SD-WAN, or you can design the data plan to connect the different edge applications in an SFC according to your own business logic.
Yeah, it does seem comprehensive, but will it take a new admin a lot of time to actually be able to operate and deploy and
No, not at all. Let me show you how easy to install the platform, and also please remember all these steps can be fully automated, which firstly make it super easy and fast. Secondly, it eliminates the human factor. After the platform is installed and registered to the edge controller, everything you need to do is to use the controller to deploy the edge application to the platform. The operation is very lightweight and the logic is very clear, straightforward. What you see is what you get. Let's start to deploy the system. First, you need to have your hardware box and put an operating system on top. And now we can start to install the edge platform elements and register it to the controller. After we register, the edge application can be deployed to the edge controller, including the SD-WAN, the Wi-Fi wall, the NDPI, or any other edge applications. And in this case, the data plan is predefined by us. It can be designed according to your own business needs. Let's take the NICs. For example, the NICs we can assign to either kernel or user space stack. In some case, even we can delegate the container, delegate to the container in if we need performances, very high performances of the NIC. And here is the edge controller GUI. You will find that right now 2 edge nodes are registered, and we can provide full control of the edge nodes here. And by click the edge node, you will get into the application list. Here, we can deploy, remove, start, stop all the edge applications. And here is an example that we can configure the interface. The network interface can be assigned to kernel or user space stack. And here is the system info. With all the applications deployed, it does not consume much resource. The computing power are reserved for other value-adding applications for your organization.
Yeah, it seems well architected and quite simple to operate, but what do we need to do, Toby, to enable that example use case?
Let's go back to our main problem, connecting two branch office sites. To configure the use case, UCP is using SweetComp as an onboard SDN agent. A netconf YARN model supported by SweetComp is implemented according to the definition from IETF. It is easy to connect the SD-WAN service to your own SDN controller. In our case, we use the SDN controller to do the configuration. First of all, we will two IPsec tunnel, one active, one backup will be configured, and BFD will be configured as well to monitoring the link status. While the BFD detect that the active link is down, and all the flow will be changed to the backup link. This feature ensures stable and secure connections between sites with two redundant secure links. Here is the example GUI of our SDN controller. You can see that it has full control to the user space stack, including the interface and routing config. And on top of this, we can also configure the advanced functionalities. Here, you can see we can configure the BFD. Our SD-WAN service can support all typical SD-WAN use cases. Beside IPsec, we can also support VXLAN over IPsec, and so on.
Yeah, so this looks excellent. I can see that you can deploy SD-WAN as a service, right, with one click. But you were, Toby, showing before in the UI screenshot that the UCP leaves some free resources. Is somebody able to use those for other purposes?
Hope you are not thinking about Bitcoin mining, but seriously, of course you can. You can run a lot of different applications on it. As the UCP is a gateway-like device, it is very important to understand the network status. At the same time, have deep view on the flows running on the device. It is important to find out those black sheeps in the system. So we deployed NDPI, which is an open source DPI, the deep packet inspection applications to our platform and mirroring all the LAN flows to that tool. Of course, this is just an example. You can deploy different types of application. For example, the video processing in a point of interest case, or like advanced analytics of traffic lights management, or even the safety ones. For example, to warn a driver approaching the crossroads about the incoming pedestrians.
Yeah, I think UCPs look like a powerful and flexible solutions. But you were showing a number of open source software components. Could you perhaps elaborate a bit on those?
Yes, of course. The benefit of using the open source components is obvious. You can utilize all the smart ideas or the excellent brands in the community at the same time shorten time to market with a reasonable cost. And we do not need to reinvent the wheel all the time, right? And in our case, three main building blocks for UCP are: the first one is VPP DPDK, which provide us a powerful, flexible, efficient, and mature user space stack. It is supported by most of the hardware platforms and NICs in the market, and easy to develop additional features to match your business needs. And the second one is the openness. It is open source lightweight edge platform. Here Intel is the initiative. The operation logic is clear and very easy to understand and operate and maintain. What is more fun, it also supports connectivity to the orchestrators like ONAP, Kubernetes, OpenStack, and other widely used platforms. What makes it even more powerful? At last, the SweetComp, SDN agent. Tito Avery is one of the initial founder of this community. It is fully following the netconf YARN model defined by IETF. It is written in C and C++, so it is a good fit for resource-limited platforms.
Yeah, looking at the software stack, is there any minimal hardware requirements, and do we have some kind of hardware specific platform that we are targeting?
No, the UCP is not an hardware sensitive platform. It can be run on any x86 platforms, no matter it is from Intel or AMD. We even perform and deploy it to ARM platform. Also, it is not resource consuming one. We do not need to deploy it to a super powerful hardware. By this limited hunger for resource, here is much more computing power left for more additional value-added edge applications.
All right, I think, Toby, thank you. I think we are getting, the top of our time for today. So perhaps we can move to the summaries. Marci, could you go first?
Yeah, sure. So first of all, what's really worth to remember from today's session is that UCP is a great example of the edge computing. It's bringing a power of the data center to the network edge, enabling many of the new data-intensive and latency-critical applications and use cases like self-driving cars, industrial automation, SDN, and many others. Same time, it's lowering operators' TCO by limiting amount of data reaching data center and core networks, and also by providing zero-touch services, deployment and operation. Second of all, the transformation is happening now, so opening new use cases, new revenue streams, and bringing a lot of benefits. And the third of all, you are not allowing this transformation. So we've been working on these technologies for quite some time already, addressing edge computing solution with a great support of technologies as OpenS, VPP, or SweetComp. We are able to create jointly specific edge solution for you. Considering also our active contribution to the edge open source communities, we can build up a solution which is best tailored for your needs and provides value for your business. If it sounds interesting, book your exclusive demo now by contacting us directly. So we'll be more than happy to discuss how edge computing solution may boost your business.
So Toby, would you like to also do a summary from your side?
Yes, Martin summarized this very nicely. I would just like to use 3 words to do the summary from my side: simple, flexible, and efficient.
Yeah, thanks. Thank you guys for the summaries. I guess from my side, I think open edge computing and UCPs are a quite exciting area for innovation and running distributed applications. and also leveraging cloud native technology as well, right? Not only in the data center, but also in the edge.
Yeah, that's completely true. So if additionally you connect your UCP, for example, to overall network orchestration software like ONAP, you're able to deploy your network services in really easy way to the part of the network like edge or cloud, or which brings you the best cost to benefit ratio based on given requirements.
All right, and looking at the time, I think with these closing words, I think it's time to move to the Q&A. Let me see questions from the list. By the way, you know, as we go with the questions, please, you can post new ones. So what is the current status of, you know, some of the use cases for edge computing today, Marcin? Can you take this one?
Oh yeah, so basically a lot of use cases have been already deployed or are deploying in the different vertical industries. So as mentioned before today, like communicated network operators, which are deploying edge computing for primarily for the support of the day network upgrades. Smart cities, for which smart buildings, traffic signaling, or use cases were assessed in addition to public safety and the public venues and utilities. It's expected that, well, in next 5 years, 4G and 5G mobile consumer and residential consumer, like a smart home, applications will come to dominate the edge computing footprint. Additionally, robust demand will also come from the enterprise IT and automotive industry vertical. So we can't really predict all the new services or business models, but as mentioned today, there are several use cases which are to benefit or are benefiting already from the edge computing solutions.
All right, thanks, Marcin. Let me check the next one. Actually, the multiple questions. So how can I access this technology? You know, what is the business model, availability, and deliverables? Toby, could you take this one?
Sure. The whole solution we have talked about today is based on pure open source software. This can be easily accessed by open source films. The open source is not connected with any license fees, and it's supported by communities. However, you may not expect it maintenance service as the commercial ones. As our solution comply with cloud native architecture, you can also make other choice to swap the cloud native applications to another solution, whether this is a commercial or open source one. If you decide to go for the commercial solution, there is a lot of blocks as used here in the market. And regarding the business model, where I'm from one vendor to another, there's, for example, there's based on bandwidth or based on instance, like the SD-WAN commercial solutions.
All right, thanks, Toby. Let me check the next one. So how long will it take to integrate a new function, let's say a commercial firewall or a DPI into the platform? Any thoughts, maybe Toby?
It will not take a long time. To integrate a new function, the only thing you do is to moving it to a container and connect the container with network service, and then it will ready to go. If the data need to forward to outside network, or you need to have some special network configuration, then some more configuration to the SD-WAN or to the vFirewall is also needed here.
Yeah, thanks, Toby. I think I guess we are running soon out of time. Maybe time for a couple of more. So next question is that how does this solution compare to existing commercial UCP solutions available in the market? Any thoughts, Marcin?
Yeah. Well, it's a very good question. So let me try to take the differences or advantages of our solution one by one. First, I would say the license fees. As our solution is open source based, well, no software cost is involved of any kind. Then for the open source, flexibility to modify and optimize the platform. Open source by nature gives high flexibility for adding new features and optimizing the solution, not only APIs. Means it can be done by yourself as wished. Then, as per the architecture, container support versus VM-focused virtualization. Not all the commercial UCP solutions in the market are ready for containers, still running services in the VMs. So they are not really giving a chance to monetize your container solution benefits. Then we are based on the cloud native principle. So the compliance with the cloud native of this solution really gives you ability to run the third-party software or the services or open source services of your choice, utilizing modular software stack. And last but not least, we cannot really forget also about some of the cons of the open source solutions, as need of having skilled staff in the house to run it or develop new features, or for example, less comprehensive maintenance services you can count on from the open source community than from commercial product software providers.
All right, there's another question about making the solution available. So the question goes, will you make the solution available on AWS Marketplace? So either you, Marcin or Toby, any thoughts on that one?
Regarding the AWS Marketplace, I think for the openness platform, I think the openness platform itself is a marketplace. So we can also publish the edge applications to the openness system. So you can have your own marketplace with your own applications.
All right, and I think maybe we're almost out of time, but maybe one last question about performance. So how is the performance of the software platform? So are there any ways to accelerate computing on the edge platform?
Yeah, so it's like a pretty long topic, as you know, and pretty wide, but let's say as you all seen today, the UCP itself and the use case we have been showing leaves a lot of room in terms of the free resources for the running additional application. But of course, if you are going to do this edge node like a multi-service device, it may happen that you will, in the end of the day, run out of the resources or try to get a better performance in terms of, for example, networking or routing or this kind of the need. But then, of course, it's you have a couple of the options. I can mention at least two ways of improving the performance or the capacity of the node without investing, a lot in the buying new servers or new nodes. The first is like a software optimization for the specific workloads. You can work on optimizing the software components running on the node by making sure that they are using all the hardware features of the platform, like like CPU pinning, when you are pinning specific process or the service to the CPU to make sure that when you are running the service is not distracted by context switching to the other task. You can consider also NUMA, like non-unified memory access architecture optimization, especially when running on the software on the multi-CPU platform, by making sure that services are running on the same NUMA node where the NIC and CPU is located. So just to avoid cross CPU data transfers. Second group of the action you can take to save even more resources or improve the performance even more is use the hardware accelerators, usually in the form factor of like a NIC card or something you can plug into the system. So the accelerators usually offloading some software computing intensive function to the hardware, like switching, like encryption, decryption in the IPsec. Also, you may want to use the GPU for the, especially for the image processing intensive application like POI, this point of interest we have mentioned today. There is a lot of already available accelerators in the SmartNICs in the market, so you can go and grab any of this, or of course we can try to select, and we can select best and integrate best for you. And all the hardware features and offloads I mentioned here are just an example. So how you can make your edge node even more capable without investing in the additional hardware nodes. All of those bring the benefit of increasing your edge node capacity for various workloads as they limit, for example, the CPU core utilization. They're improving also performance and, well, overall TCO.
All right, thanks, Martin. I think it's time to close. Thanks everyone for your kind time today, and of course, thank you guys, Martin and Toby, for your insight.
And thanks, Mikhail and Martin, and thank you all for participating.
Yeah, thank you, everybody. I hope to hear back from you soon, so we can join forces and work on the edge solutions right together.
All right. I think we hope everyone had enjoyed the webinar and perhaps learned something new. And if you want to see the UCP in action rather than in the slides, please don't hesitate to contact us to book a demo. And if you have any other questions, please let us know through email or give us a call, and we'll come back to you. So, but wherever you are, we wish you a good and safe day. So, thank you.
Thank you.